Good afternoon. So today we are going to do experiment number 4 under the machining portion of the lab. So we are going to study effect of process parameter and pilot hole on mechanics of drilling. By mechanics of drilling, we will be primarily talking about forces and energy in drilling. Let us summarize what we have done thus far. We have done 3 experiments. Experiment number 1, experiment number 2 and experiment number 3. All of them, they are on different machining characteristics. One is on chip characteristics, one is on cutting forces and energy, another one is on cutting temperature. These are very important machinability characteristics. The process that we have taken is turning. Today we are going to change the process. Today our process is drilling instead of turning. However, the important machinability characteristics like forces and energy that we are going to study. One experiment would be remaining. There also we will be changing the process once again. We will be going towards the grinding process, which is a finishing operation. There also you will be studying forces and energy. However, let us concentrate on today's experiment, which is effect of process parameter and pilot hole in drilling on mechanics of drilling. That is the title of today's experiment. Now let us have a look at the drill. So we need to understand what are the process parameters, what are the tool materials, and what are the cutting edges. The tool materials which are typically used in case of drills, they are high speed steel, solid carbide, that means tungsten carbide plus cobalt plus titanium carbide, that kind of thing, and coated tools. Coated tools means both coated HSS and coated carbides. So these are the different types of tool materials which are used in drilling. Now let us look at process parameters. As you know, the process parameter in machining is VC, S and T, that is cutting speed, feed and depth of cut. In case of drilling, this is the diameter of the hole. This is also the diameter of the drill. So this is D, or diameter of the cutter DC. So VC, cutting velocity, is given as this, where this is the RPM of the drill. So drill is rotating in this direction. So N is the RPM of the drill. This is the diameter of the drill in millimeter, and this cutting velocity or cutting speed will come out in meter per minute. What about S? As the drill is rotating, the drill gradually comes downward. As the drill is rotating and removing material, the drill is fed in this direction. So this feed is nothing but S, which is expressed in millimeter per revolution of the workpiece. What is depth of cut? This is depth of cut. This is the depth of cut expressed in millimeter for the cutting edges. I have to explain what are the cutting edges, then only the concept of depth of cut will become clear. As you can see, this is a typical HSS twist drill. These are the flutes through which the removed material will come out. This is one particular cutting edge. This is the main cutting edge. This is another cutting edge number 2. And these two cutting edges, they are joined by another one which is called chisel edge. At the main cutting edge, that is chisel edge, cutting edge number 1 and 2, you have proper chip formation. However, at the chisel edge, the rake angle is not favorable, it is unfavorable. That means rake angle is negative. So this is unfavorable. And at the chisel edge, quite often, instead of chip formation, extrusion like failure of the work material takes place. So this is something about the cutting edges. As you can see, this is one cutting edge, this is another cutting edge, and so this is the depth of cut, which is d by 2. So depth of cut in case of drilling is dc by 2. This has got nothing to do with number of cutting edges. Each one of them, they are removing this much of material, so it is dc by 2. So that is the depth of cut. Now let us come to what you have to do. We have to do two types of experiment, one with pilot hole, one without pilot hole. So this is without pilot hole, another one is with pilot hole. What is pilot hole? We will explain later on, but let us see what you have to do. You have to study the effect of cutting velocity, feed and drill diameter. So this is your VC, this is your A and S, and drill diameter is DC, which is related to depth of cut. So this is nothing but this. On thrust force and torque while drilling low carbon steel with uncoated HSS drill. So we are not using a coated drill, we are using an uncoated drill. And we will also study the effect of pilot hole and process parameter on the same thing. So in the first objective, your work material would not be having pilot hole, and in the second objective, your work material would have pilot hole. During drilling, we will come to that. We have not explained or we have not shown you what is thrust force and torque. We will come to that when the appropriate slide comes. So these are the experimental conditions. This would be done in a radial drilling machine. So if you have not seen a radial drilling machine or you do not know a radial drilling machine, please find out from books or from other internet resources. It is a low carbon steel. Low carbon steel means its carbon percentage is typically around 0.2% or less. So that is, and doesn't have any alloying element. It is a plain carbon steel. These are the two drill diameters, 8 mm and 10 mm for objective 1. For objective 2 also the drill diameters remains 8 and 10 mm. Only thing is that the pilot hole diameters become 2.5 mm for 8 mm drill and 3.5 mm for 10 mm drill. We will be using a piezoelectric 3-axis drilling dynamometer made by Kistler, and we will be using single channel universal charge amplifier made by Kistler. And we would also have a storage oscilloscope where we will be acquiring the force signal and the torque signal. There would be a demo video along with this. That would be uploaded separately. All the arrangements you can see in the demo video very clearly. Now let us come to the procedures. Note down all the available speed and feed combination on the machine tools. This would be done by the operator who has done the experiment for you. Drill diameter would be 8 and 10 mm uncoated twist drill. Feeds which would be chosen as 0.12 mm and 0.2 mm. This will give you the effect of feed. This variation will give you effect of depth of cut. And choose cutting velocity at two levels between 8 meter per minute and 25 meter per minute. As because we are not using a CNC machine, we cannot say carry out the experiment exactly at 10 meter per minute and 20 meter per minute. So whatever would be available, that would be there, and this will give you the effect of cutting velocity. Prepare the datasheet. Datasheet would be shown to you. Set up the force measurement system. Measure the thrust force and cutting torque as per datasheet. This is for experiment number 1. You have to do 8 experiments. Why you have to do 8 experiments? Because there are 2 VCs, there are 2 feeds, there are 2 kinds of depth of cuts, and so you would have to carry out 8 experiments. What else do you need to do? This is objective number 2. Same experiment you have to repeat, same kind of feed, same kind of cutting velocity. Only thing is that now there would be a pilot hole of 3.5 mm and 2.5 millimeter respectively for 10 millimeter diameter drill and 8 millimeter diameter drill. Rest of the procedure remains same. Now what is pilot hole? Let me explain that. Before that, let me tell you what are the forces which will be coming onto the drill. So the forces which will be coming onto the drill can be shown here. There would be a force which would be in the upward direction. This should be called thrust force. And there would also be a cutting torque which would be coming. Okay, there would be no radial force, because radial force generated by CE1 would be cancelled by CE2. So these two will cancel each other, so there would not be any radial force. Now what is pilot hole? Just under the chisel edge, if you remove the material, so this is a work material where there is a pre-existing hole. This diameter of the hole this is called a pilot hole, and this is the pilot hole diameter. That means so that the chisel edge does not participate in the final hole making process. Why it should not participate? That we will explain later on once we look at the data. So this is the pilot hole. So in objective number 1, your drill diameters are 8 millimeters and 10 millimeters. This is also so in case of objective number 2. However, in objective number 2, for 8 millimeter drill diameter, there is a pre-existing pilot hole of 2.5 millimeter, and for 10 millimeter drill diameter, there is a pre-existing pilot hole of 3.5 millimeter, I believe. I might be wrong, let me have a look. Yes, 3.5 millimeter. Okay, so this is the arrangement that we are going to do. And typically the pilot, the chisel edge diameter, if this is the chisel edge diameter, typically in case of HSS drill is 1/6 of the drill diameter. So that is it. So that is the thing. So we have made the pilot hole larger than chisel edge diameter, so that chisel edge does not participate in the hole making process at all. Now this is the result without pilot hole. That means there is a solid workpiece which you are drilling. You are drilling for the first 4 experiment with 10 millimeter and the second 4 experiment with 8 millimeter. If you compare this, here you have increased feed. As you increase feed, you can clearly see the forces, both the torque and the thrust forces, they are going up. And it is happening everywhere. Everywhere it is happening. As far as effect of speed is concerned, this is the RPM. The cutting velocity is not reported. You have to report cutting velocity. For calculating cutting velocity, as I said, this equation has to be used. But you can say as the RPM is going up, cutting velocity is also going up. So you have to compare with this blue block with this red block. And if you compare, there is not much effect. There is slight effect, but not much. If you go to 8 millimeter drill diameter, same thing you observe. As you increase your feed, the torque goes up, the forces would also go up. And it is happening everywhere. One thing you can note here is that thrust force is more than 1000 Newton. Quite often it is as much as 1700 Newton. Now, once you introduced a pilot hole, just below the chisel edge, let us see what happens. Now, this was the thrust force, 1700. That thrust force has come down drastically. Rest of the story remains same. If you increase your feed, torque goes up, thrust force goes up, and it is valid everywhere throughout the experiment. There is no departure from that. But what you observe is that there is significant reduction in thrust force. Let us compare it in a better manner. So now this is the thrust force without pilot hole, and this is the thrust force with pilot hole. That means that small chisel edge is primarily generating so much of thrust force in drilling. So if you do not allow the chisel edge to participate in the cutting process by putting a pre-existing hole, your thrust force on the cutting tool goes down tremendously. It is almost say around 1500 and here it is around 300. So it is very less. It is almost 5 times less or 4.5 times less. So 80% of the thrust force is generated by the small chisel edge. However, if you compare the torque is also going down. It is 560 and it is going down to 770, but it is not going down to 80% on stuff like that. Everywhere it is the same story. So this is a question which should be asked in your report and you have to find out the answer for this. So what you have to do, first thing you have to do is that from the data you have to calculate specific cutting energy. That we will do. I will show you. Draw the variation in thrust force, torque and specific cutting energy with process parameter and geometrical parameter. Explain the nature of variation. Why thrust force is so high in case of drilling unlike turning, and compare the effect of pilot hole in thrust force and cutting torque. So there is no direct question that why thrust force goes down by 80% or so but torque doesn't go down, but it can definitely, if you are not writing even it in the report, it can definitely be asked in your examination. So search for that particular answer and try to do. I will give you a small hint. Torque is basically forces which are coming into the diameter divided by 2, and at the chisel edge diameter is very less, so possibly the contribution of the chisel edge on the torque is less. But please investigate or verify this particular statement and analyze this particular statement. Now how do you calculate specific cutting energy? Specific cutting energy is calculated as power divided by material removal rate as it is given here. So first you have to calculate material removal rate. This is without pilot hole and this is with pilot hole. So with pilot hole, without pilot hole it is pi by 4 d square into s into n by s. So this particular whole thing will come out in millimeter per second. This 60 is there in the denominator to convert it from millimeter per minute to millimeter per second. This will come out in millimeter square. So the whole thing MRR will come out in millimeter cube per second. As far as with pilot hole is concerned, nothing but the area has to be negated. So d square minus dp square. So this one is in millimeter square, and this one once again is in millimeter per second. So this one will once again come out in millimeter cube per second. So both the MRRs would be same. In fact, this is the general equation where dp is equal to 0 will give you without pilot hole. Now how do you calculate power? It is the cutting torque into the angular speed. Cutting torque has to be in Newton per meter and the angular speed has to be in radian per second. Angular speed is given in RPM, that is divided by 60 to get it in RPS, that is multiplied by 2 pi to get this whole thing in radian per second. So you calculate power and then you calculate UC. Let us go back to the data just once. Please note all the data which are given, this is Newton per centimeter, this is Newton per Newton. So this Newton per centimeter has to be converted. And once again, let me write down, this is Newton, this is Newton per centimeter. This particular block I have put here just to compare this block with respect to this block, what I have done just few minutes back. So this has got nothing to do with pilot hole diameter. Okay. So this is it. In this way you have to prepare the report. What has to be written in the report is clearly given here. When you have to submit the report, what is the last date, to whom you have to submit, all those informations you will get in Microsoft Teams channel, respective channel. Along with this video, a demo video will be uploaded. Please go through the demo video as well. Then only you will be able to appreciate the rigor of the experiment. Thank you so much.